Right now, part of your brain is scanning the room for a predator. Not a metaphor, an actual predator. The kind with claws and teeth that could kill you in seconds. It is doing this even though nothing like that has been anywhere near you or almost anyone you know in more than 10,000 years. Your heart does not know the difference between danger and a deadline. Neither does the part of your brain running this scan. That is why your palms can go damp before a meeting that carries no physical risk at all, and why your chest can tighten at the sound of a notification you have not even read yet. So why does your body prepare to fight a lion when the only thing chasing you is an unread email? Here is the fact you can carry away even if you stop watching in the next 10 seconds. A structure in your brain no bigger than an almond can trigger a full fear response in a fraction of a second, faster than the thinking part of your brain can even register what you saw. By the end of this video, you will know exactly why that structure exists, why it was built to overreact on purpose, and why more than 300 million people alive today are dealing with that exact same circuit misfiring on modern life instead of ancient danger. So, where does this reaction actually begin? It begins in a structure called the amygdala, an almond-shaped cluster of cells sitting almost exactly in the center of your skull. Picture a smoke detector bolted to a ceiling before you ever moved into the house. It knows nothing about your job, your relationships, or what century you live in. Its only setting is loud, and its only task is to scream the instant it senses anything resembling smoke. Your amygdala works on the same principle. It is deaf to context and blind to nuance, built for one job only: sound the alarm first, sort out the details later. Neuroscientist Joseph LeDoux at New York University mapped the exact wiring behind this reflex in research published in 2000 in the Annual Review of Neuroscience, more than 20 years ago now. So how fast does that alarm actually go off? Faster than you can consciously think. LeDoux found that a threat signal can travel directly from your eyes or ears to your amygdala, skipping the slower reasoning part of your brain completely. That means your body can start reacting to danger before you have even finished figuring out what you are looking at. On the open savanna, that shortcut was the difference between living and not living. But it also means your amygdala cannot tell the difference between a genuine predator and a red notification bubble on your phone. Because as far as that ancient shortcut is concerned, both register as exactly one thing: possible danger, respond now. And what actually happens inside your body once that alarm fires? Your adrenal glands release adrenaline directly into your bloodstream. Your heart rate spikes, pulling blood away from your stomach and into your arms and legs. Your pupils widen to let in more light, and your breathing speeds up to pull in more oxygen. None of this is a choice you make. Your body decides for you, faster than conscious thought, because thought is slow, and a genuine threat is not. Physiologist Walter Cannon documented this exact chain of events in 1915, more than 100 years ago, in a book called Bodily Changes in Pain, Hunger, Fear, and Rage, where he gave this whole body reaction the name still used today, the fight or flight response. So why would evolution build an alarm this jumpy in the first place? Because a jumpy alarm is cheaper than an accurate one. Imagine two early humans standing at the edge of a forest. One of them treats every sound as a possible threat and freezes constantly, sometimes for nothing. The other only reacts when she is absolutely certain danger is real. On most days, the second one saves time and energy, but it only takes one real predator, one single time, for that difference to become permanent. Because the first woman survives to have children, and the second one, on the day she is wrong, does not. In 2001, more than 20 decades ago, Randolph Nesse, then a professor of psychiatry at the University of Michigan, described exactly why natural selection favors the jumpy one in a paper published in the Annals of the New York Academy of Sciences that he titled The Smoke Detector Principle.
And what does that math actually look like? A false alarm costs you a few wasted seconds. Your heart races, then it settles, and life continues. A missed real threat costs you your life permanently with no second chance to pass on your genes. So evolution did not build a perfectly accurate threat detector. It built one that goes off too often on purpose, because too often is enormously cheaper than too late. That single piece of math is the entire reason your amygdala treats a work deadline with the same urgency as a predator. From a purely evolutionary accounting standpoint, overreacting has almost no cost, and underreacting can end your bloodline.
Is that jumpiness only about physical danger, or does it shape how you experience good and bad more broadly? It goes further than danger alone. Picture a video game where losing 10 points stings far more than gaining 10 points feels good, even though the numbers on the screen are exactly the same size. In a study published in 2001 in the journal Review of General Psychology, psychologist Roy Baumeister and his co-authors showed that this same lopsided weighting runs through nearly every part of human life. Bad experiences affect people more strongly and linger longer than good experiences of equal size. Researchers call this the negativity bias. It exists for the same reason the smoke detector in your amygdala exists. Missing one good berry bush cost your ancestors a snack, but missing one predator, one hostile stranger, or one poisonous plant could cost them their life. The ancestors who paid closer attention to danger were simply more likely to survive long enough to have children, and every person watching this video is descended from the ones who worried.
Where does this bias show up most obviously in your day-to-day life? Look at how you use your phone. A single harsh comment on something you posted can occupy your attention for hours, replayed and reanalyzed, while 10 kind comments on the same post barely register before you scroll past them. That is not a personal weakness, it is the negativity bias, doing to a comment section exactly what it once did to a rustle in the grass, treating the one bad signal as more urgent and more important than all the good signals combined. Because for most of your species' history, the bad signal was the one that could actually kill you. So, if this system was built for a world of predators and berry bushes, why does it still run your life in a world of phones and offices? Because your amygdala has no calendar. It cannot check what year it is, and it has no way of knowing that the modern world removed almost all of the physical dangers it was built to detect. So it keeps doing the only job it has ever had, aimed at whatever looks even slightly threatening. A stranger's expression, a notification sound, a deadline on a calendar app. This is why, at some point during an ordinary week, you have probably felt your pulse spike before opening an email from your boss, or felt your stomach drop before walking into a room of people you do not know. Not because anything in that moment could actually hurt you,
but because the exact same ancient circuit that once scanned the grass for movement is now scanning your inbox.
Why would something as harmless as a room full of strangers trigger a survival-level response at all? Because for the vast majority of human history, being rejected by your group was not a minor social discomfort. It was a survival emergency. Homo sapiens has existed for roughly 300,000 years. Farming, permanent villages, and written law are all much more recent, appearing only in the last 10,000 years or so. That means for more than 95% of your species' entire timeline, your ancestors lived in small, mobile groups with no permanent homes, no police, and no hospitals. If your group turned against you or cast you out entirely, you lost access to food, protection, and safety, alone in an environment that could kill you in a dozen different ways. Your amygdala still treats social rejection as if it carries that same weight, because for almost the entire history of your species, it genuinely did. So how many people right now are actually dealing with this ancient circuit misfiring on the modern world? More than you might expect. In a study published in 2021 in the journal Epidemiology and Psychiatric Sciences, researchers Xiaorong Yang and colleagues, analyzing global health data collected through 2019, estimated that 301,390,000 people worldwide were living with an anxiety disorder that year. Because that number is already several years old by the time you are hearing it, the real figure today is almost certainly higher. To make that scale concrete, 300 million people is close to the entire population of the United States. Every single person, all experiencing some version of the same ancient alarm system, responding to a century it was never built for. Does knowing all this actually change anything? It changes what the reaction means. The next time your palms sweat before a difficult conversation or your chest tightens before a deadline, that is not evidence that something is wrong with you. It is your amygdala doing exactly the job natural selection built it to do, using the only method it has ever had, several thousand years behind schedule. The circuit is not broken. It is simply still running the software of a world with lions in the grass, applied to a world that replaced the grass with inboxes, group chats, and glowing rectangles that buzz in your pocket. You cannot switch the circuit off, and you do not need to. You only need to recognize it for what it actually is, an alarm doing its job, not a verdict on your character. So the next time your body reacts like you are being hunted, remember what is actually happening. Somewhere behind your eyes, a structure the size of an almond is still scanning the room for a predator. And for the first time, now you know exactly why.